So what we're doing today is we are working on the sheet from page 49. We started yesterday, so we're looking, we've got the base paper. We've got the base paper. We've got one flip out that says relationships, and then we're gonna have another one piece of vellum paper that will be our connection. So right now, we're on the first one that we started last class. So I'm looking here at relationships. So these are components of the water cycle. So energy, so we did the one, so I'm gonna go read the one from yesterday. So energy transfer from the sun warms water on Earth, which can evaporate in the atmosphere. So we had sun, energy transfer, warms the water, evaporates. And we added in a key of energy and water. So now we're looking at number 2. And once again, we're looking to see if there's extra components that we need to add in, and also what modeling tools we need to be using to express this. Water vapor in the atmosphere forms clouds, which can cool and condense to produce precipitation that falls to the surface of the Earth. So let's look at the first part. Water vapor in the atmosphere forms clouds. So is this first part about water vapor in the atmosphere forms clouds? Is it moving, or is it like kind of stationary?
Moving. No, wait,
So it's stationary. So when we're talking about stationary, we're not going to be using what modeling tool? We're not going to use what here? Arrows. Okay, so arrows show movement. So this first part is just stationary. So looking at page 9, can you see what might be a tool that shows kind of an explanation piece? So we're not using arrows here, so look at page 9. What modeling tool would you recommend that we use for this? And you can just kind of, so am I asking, if I'm talking about zoom-ins, I'd be looking for molecules. I don't have anything about molecules here. What do you think? Yeah. Okay, great. So we're gonna do a call out here. So we're up in the atmosphere. Water vapor in the atmosphere forms clouds, which can cool and condense to produce precipitation. So I'm gonna be talking about water vapor can cool and condense to produce clouds. So I'm up here in the clouds, or in the atmosphere, sorry, water vapor cools and condenses. Let's put that on this one. Cools and condenses to form clouds. Okay, so this is the first part of number 2. So water cools and condenses to form clouds. And when I'm doing a call, and I want to be thinking about where on my model, and I know this is only one of the few models we've done so far, where on the model do I want to highlight? So I'm talking about in the clouds, so I would be connecting to the cloud. So I'm going to have like a little kind of piece popping out to this cloud, maybe a little piece popping out to this other cloud, and then I'm going to be forming a box around it. So right now I'm just using a regular pencil. Okay. So then I'm going to constantly kind of read to make sure that I'm using all of the pieces, or I'm connecting the pieces that it's asking me to. So water vapor in the atmosphere forms clouds, which can cool and condense to produce precipitation that falls to the surface. So give me a bobblehead. Did I cover all of this? Bobblehead yes, or bobblehead no? Okay, so now I'm missing something. So what word did I not include here? Whisper to the person next to you. What word did I not include? So precipitation. Do we see examples of precipitation already on this diagram? Yes, okay. So the rain and the snow. So in this case, is it moving or not? Give me a bobblehead.
Yes.
Those were loud bobbleheads, yes. So if it's a moving, we're gonna use, tell me everybody? Arrows. Okay, so I'm gonna show an arrow going down, and then I'm going to label. So we can't have any naked arrows, so I'm going to label this as precipitation. And once again, we would normally have a much bigger diagram, but because this vellum paper is expensive, we are just doing small little things. So those of you that have big handwriting, my apologies. Okay, so now we've done all of number 2, so I'm gonna check number 2 off. Then I'm gonna read the next one, and once again, with this first overlay, we're looking at relationships between components. So we're seeing, are we adding in components? So far we've had energy, we've had water, so we're kind of looking for components that we need to add in and then kind of making the notes about what's happening. So gravity causes water on land to move downhill. Example, rivers and glaciers, and much of it eventually flows to the ocean. So gravity causes water on land to move downhill. Example, rivers and glaciers, and much of it eventually flows into the ocean. Do we have a new component here?
Yeah.
Okay, raise your hand if you want to share with you what you think the new component is. Yeah.
Returning or having it return back to the bigger body of water.
Okay, but so the body of water, we already have a body of water. So we already have water, okay? So that, even though it's a specific example, it's not necessarily a new component. Yes?
Gravity?
Okay, so gravity is gonna be the new component. So gravity doesn't necessarily have a color, but for the purposes of,
Purple.
we're gonna just do purple. It doesn't look too purple, but it is on mine. So we're gonna add in purple to our key.
What does that say on like the blue line?
I'm sorry, where?
Like the blue line on the cloud?
Oh, precipitation. Okay, so let's see what it says. Gravity causes water on land to move downhill, and much of it eventually flows to the water. So we know that if we were to drop something, okay, gravity is, if we had to draw an arrow for gravity, that arrow is going to be pointing down, okay, towards the ground. In 6th grade, once again, you haven't really talked about forces. You'll go really into depth in forces into 8th grade. So obviously, the force of gravity is going to be a downward arrow. But for the purposes of what we're trying to show on this, even though it's not as exactly scientifically accurate as we would like it to be, we're going to show the cause of gravity moving down, kind of like diagonally on the hill. But know that the force of gravity actually is pulling straight down towards the center of the Earth. So here we have precipitation, and we're going to show gravity kind of heading down this hill. Once
Down
again.
River Valley.
Yeah, down that river valley, okay. So I just have this, great, then that's purple.
Should we do purple on the glacier?
No, because the glacier is not, we're not gonna do that part there, but thank you for asking. Okay, so gravity causes water and land to move downhill. So we're gonna label this arrow gravity. Even though it is color coordinated, it's just gonna make it a little bit easier for our reader a little bit later. But we need to explain that to our reader. So we need to explain that gravity causes water and land to move downhill, example, rivers and glaciers, and much of it eventually flows to the ocean. So I'm gonna, once again, if I'm trying to explain something with a little bit more detail, whisper to the person next to you what modeling tool would be most helpful to give me an explanation. Okay, call it, great. So I have to think about where I want to put this, okay? So I just know where I'm going, so I'm gonna say that there's gonna be some stuff over here. So yeah, I'm gonna put it down in this area, because I'm not gonna be putting much else in the water.
Why not on the
What I was just saying is, there's gonna be more pieces, and I know that if I were to read it all first, which we're not doing, that we're gonna have stuff connected in here, so. But, okay, so, let's kind of read it, what it says again. It says, gravity causes water on land to move downhill, and much of it flows to the ocean, so I'm gonna kind of put that down here. Gravity. Sorry, thank you. Gravity causes water to move downhill. And much of that flows to the ocean. So we need to take this and we need to connect it with what we just did on the, so I'm gonna make my call out, I'm gonna connect it to that piece, and then from there, I'm gonna draw my box. And you can kind of pick a style. You can decide to do like all sentences or kind of like more just kind of, you know, I'm going to go with sentences here. Okay. Gravity causes water to move downhill, and much of that flows to the ocean. So I'm kind of checking off that I have done number 3. So let's look at number 4. Some liquid and solid water remain on land and in the form of bodies of water and ice sheets. Some liquid and solid water remains on the land in the form of bodies of water and ice sheets. So I'm thinking, is stuff moving here or is stuff staying the same? So I want you to underline the word that you think indicates that it's either staying or it's moving. So what word, with the person next to you, what word is kind of cluing you in? Tell me out loud. Remains. Okay, great. So because it's staying, we are not going to be using what, everybody?
Era.
Great. So in this case, we're also going to use another.
Call out.
Great. So when once again, for those of you who remember, you have to be looking at me, and I know not all of you are, but like when I'm putting my hand up to the air, that means all of you can kind of speak out. So some liquid and water remains on land in the form of body and water, and on others in ice sheets. So I'm just saying, and once again, I appreciate like Henry noticing we have a big space here. I'm going to put it over the side because I know something else is going to go here later, so I'm just going to kind of clue you into where.
Oh, we can't see.
Okay, you can't see. Thank you. Okay, so I'm kind of summarizing some liquid and solid stays on land. And you could give more detail as, you know, bodies of water, as ice sheets, but I'm going to just point to them. I'm going to point to the glaciers, and I'm going to point to, a tributary. Great.
What's a tributary?
So, yeah, so once again, when you have water that's kind of going into a larger body, like a river or something like that, that would be a tributary. It would be a smaller piece coming to join. Okay. Now, what you can kind of see is we've got a number. So I've got this one, number 4. I've gone to the ice sheets. I've gone to bodies of water. So at this point, I have a number of call-outs. What I can think about, and typically you would do this maybe at the end, but I just want to kind of start maybe drawing our attention to it, is it starts to, so this is it's going to be a very full model because we have lots of pieces on here, but you can think about how can I maybe add in some ways to pop these call outs so that it's a little bit easier for my reader to understand what's going on.
Sharpie.
So what kind of technique might I use to kind of draw more attention to these? Okay, so adding some color. But we want to be thinking about when we're adding color, can we be really intentional with our colors? So we want to be adding color in what we say is like a meaningful way. So we've got some colors here. So what I want to do is I want to use those same colors in around these boxes to draw attention to the different components of our thing.
So
Yes.
like the one that's down on the beach would be purple because it's gravity.
Correct. So the one down here, great. So let's kind of,
So just highlight it.
we're just going to outline that. So I'm just doing the same color because it's got about gravity. Okay, and then the one on the top, water vapor cools and condenses to form cloud. Which color is most relevant here? Okay, so. And then some liquid and some solid. Oopsie, I should have put the word water in there. Stays on the land.
Solid water.
Yes, uh-huh.
Miss Newbern, I think you missed number 5.
We're not finished yet.
Oh, okay.
Okay, and now this, when I start to put it in blue, then it kind of draws a little bit more attention to this little kind of pointing out piece. So one, it makes it more visually appealing, but it also kind of adds an extra layer of support to your reader to kind of make those connections for them. so let's look at the last one, number 5. Some water remains in the tissues of plants and other living organisms, and this water is released when the tissue decomposes. So do we have any new components? If so, I want you to underline them. Okay, so looking at this sentence, some water remains in the tissue of plants and other organisms, and this water is released when tissues decompose. So whisper to the person next to you, what is the new component?
And other living organisms.
Great, so we have this here. Okay, and are we seeing movement, Vivian Bobblehead, are we seeing movement here? Originally, some, in the first part, some water remains in the tissue of plants. Movement? No, okay. We've got remains here again. So we've got a new component, so we're gonna add it to our key. So my key is a little bit running out of space, so I'm gonna put it on the top. What color would be good? Tell the person next to you, great, awesome, green. Now, so we're adding in, I'm just gonna put plants as opposed to and other living organisms, because we wanna be thinking about CCC. So what we have the CCC of scale. So with this, so an organism is one individual of the species. So at this scale, we're not really necessarily seeing an individual. We can't see an individual bear or probably even an individual tree at this scale. So I'm not gonna really do the plants and, but it could be maybe in our writing. Okay, so I'm going in and I'm gonna color in the forest. Okay, so let's now kind of put it together. Some water remains in the tissue of plants and other living organisms. So I could put that down here. And I'm looking at number 5, and then I'm kind of writing about it. So some water remains. I could also be at this point doing more, paraphrasing. Some water stays in the tissues of plants and animals. And actually other organisms, because it could be bacteria as well. So, and other organisms, we should maybe just use organisms instead.
Call-outs to all 3 of the forests, I guess?
So you don't need to, you could. I'm gonna just do it maybe just to one. I mean, I could do it to another one, but if I start doing it to both, you see I'm gonna start getting crossovers of my call-outs. Some water remains in the tissue of plants and other organisms.
Can we highlight that, call out in green?
Uh-huh. So I'm gonna hold off on doing the coloring because I have to make another one and I just wanna make sure I have space and I don't need to shift stuff around. Because sometimes what'll happen is you'll put stuff together and then you realize you need to move something around because you didn't plan well enough. So, and when you start to color, then you kind of get yourself stuck. So let's see. So some water remains in the tissues of plants and living organisms. So we have that taken care of. And water is released when the tissue decomposes. How are we going to show water decomposes in tissue? Can we see that at this scale? What modeling tool on page 9, tell the person next to you, is going to be, so this is where we need to zoom in. So once again, and when you're doing a zoom in, you need to have a circle. Okay, so we're going to have a circle. Now, if you didn't plan a lot, you might have to use the inner circle, which normally would be way too small, but this is a really shrunk down more than I would say. So I probably got enough space for a big circle, but you might have to use a small circle for this one. And I'm zooming into something that's living. So I'm zooming into like a forest here. What part, I could draw a whole tree, but also what else could I show might be? Okay, so what else might I show? What part of a tree might be decomposing? That would be easy to draw.
Trunk, a leaf.
A leaf, okay, so a leaf, okay. So once again, you could draw any part, but I'm just gonna go with a leaf because that's something that I could easily.
The inner circle.
It's fine. Okay, so I have a leaf. And I'm gonna show that it's decomposing, so I'm going to be maybe using brown or even orange or something like that. Okay, I'm gonna label that it's a decomposing leaf.
Wait, could I have done an apple?
Okay, once again,
Maybe
it's,
I should have done an apple.
okay.
Apples decompose.
So I'm writing decomposing leaf, and then,
Grow on trees.
okay. So I'm looking here, so some water remains in the tissue of plants, we got the first part. This water is released when the tissue decomposes. So this water is released when, which way, so we're showing released. Tell the person next to you, what modeling tool are we showing the
Arrow
released?
upwards.
Air. Can it go up? Could it maybe go into the atmosphere?
Yeah. Yes.
Could it go into the ground too? Yes, so let's have arrows going both ways. And then we're gonna write about that in a little call out.
There's
Okay,
no way. I do it over by the lake and river, or are we gonna do that? Some of the
so
later?
this is the last one. So water is released when tissue decomposes. Okay, and then I'm going to connect. Okay, and then I'm going to go back in and I'm going to start to put my last colors on. So 5 checked off. Water is released when tissue decomposes. So let's look at these two call-outs that we just did and see what color we think makes most sense to put these in. So some water remains in the tissues of plants and other animals. So water's gonna be relevant for all of them, but if there's another component, then that would make more sense. So the green is gonna pop out a little bit more here for us, because we're actually talking about the tissues of the plants.
Did we also highlight the little zoom in with green?
Okay, and then here we have this other one, water's released when the tissue decomposes.
Blue. Green. No, green.
Okay, green.
What about the decomposing leaf? Should we highlight that green?
Okay, and what do people think about that suggestion? Do you want it, we could also do the zoom in.
Yes.
In, and once again, I'm gonna go back to my, okay? So now this makes it a little bit more, that was not super obvious, okay? So I'm gonna give you the instructions for the next piece, okay? So this is the first piece. So this was all about components of the water cycle. We had plants, energy, water, gravity. Now what we're gonna do is we're gonna flip this up. We're gonna flip up the one. You gotta pay attention, you gotta stick with me.
It looks like nuts.
And you're gonna put the next one on, okay?
Oh my god. I haven't done
And now we're gonna, so we're now about to move to the second piece. So the second piece is connection. So we're gonna write on connections here.
Where?
Thank you. Connections. Okay, so now we're here. We're doing connections.
What if you read at the top of the other one?
Relationships. So I'm gonna read the thing together. So energy from light and the force of gravity drive water cycling between oceans and the atmosphere and land. So there are 5 parts. Okay, there are 5 parts. Okay. So what's gonna happen is you as a table group are gonna try to work your way through these to the best of your ability. You're gonna think about, like, I'm gonna read the first one to you and you're gonna see what new stuff do you need to add. So energy from the sun drives the movement of water from earth, oceans, landforms, and plants in the atmosphere, transpiration and evaporation. Have we seen, give me a bobblehead, have we seen energies from the sun drives the movement of water?
Yeah.
Okay. Have we seen transpiration yet? Have we seen evaporation yet?
Yes.
Okay, so as you're doing it, you're gonna focus on things that you haven't seen before. If you talk about evaporation, I would say if you want to add evaporation in, I want you to focus on states of matter. So you might be on to your original arrow about evaporation. You might be telling me, is it going from a solid to a liquid or a liquid to a gas? So on the arrows that you already have, you might be adding in things like this.
Wait, so we're going back to the first one?
So we're on this diagram here.
Yeah.
You're gonna do the best you can to read this, see how would you add in transpiration. If you wanted to add in evaporation, like what would you add that might be different? So you might add on, you might be like, okay, here's my original one. And then I could add the arrow and then just go, what changes of states of matter are happening? If there's a change of states of matter. If not, then don't put it there. Okay, so facilitators, you are the clubs for today. You're gonna get your group started. You're gonna read, figure out what,
Wait, why did you switch in the middle of the
okay, facilitators are the clubs. They're gonna be reading and getting you started. I'll check in with you in a couple minutes to see what modeling tools you use for transpiration.